fourth disc needs to be made perfectly correct before the lock will open, but all the others are probably fine. Now, that lock did take quite a bit of time to open, but if you look at the code is, from tip to bow, is 0050 2155 320. So there are actually 3 5s in this lock, and of course 5s take longer to get to than others. I've come across locks that didn't have any 5s, and some that only had a couple of 4s as well. But that would have obviously been a lot quicker to get to. Plus also the lock is a bit tight, and I'm having to use quite a lot of tolerance to get the pieces to move. But it's not unusual to come across locks that you do open in sort of 5 minutes and less. It's just a matter of the speed of how quick you're capable of changing the little pieces and how good it's responding each time. Sometimes you go into the lock and you only get one response on any disc at any one time. Other times you go into the lock and you get 3 or 4 discs binding at the same time. If you get more than that, I wouldn't start trying to change them all. There's a chance that something's a little bit amiss and maybe the discs are off alignment and they're pressing on two, or the pieces are under alignment and they're pushing on 2 discs at the same time. So don't change more than 2 or 3 pieces at any one time, but you know, you could open it quick if there's not a lot of deep cuts. Now, having developed this system and having developed the other one, which is identical but just slightly bigger for the 7.5mm profiled version, people are probably saying, well, why do we need the other system? Well, the other system has got its advantages as well. It certainly, on certain locks, can be very quick. So I would still want to keep the old system because there are things that I would do that I would prefer to do with the other system. Plus, it's a good fallback. The other system did give you, for example, with the shim wire decoder, it was very quick. It didn't take more than 2 minutes to go up the 11 discs inside the lock with the shim wire decoder and have the code. If you have both systems, you can use the shim wire decoder to identify what you think the code is, put that code onto this tool, and then go into the tool and use this as a key to open the lock. If you've made a mistake on the shim wire decoder, it will be very obvious where the mistake is, because as soon as you go to the correct piece inside this and it goes rigid, you know that that's where the mistake was. And that was the problem with the shim wire decoder. It was quick, but it was quite often a little bit inaccurate. Sometimes the wire would go into a 2 gate, although it was a number 3 code, and so on and so forth. So by using the 2 systems together, it can be very quick. Now, a lot of agencies do use endoscopes to defeat these locks. It is possible to compress the top disc and introduce an endoscope at the top of the sidebar, and then look down the sidebar and rotate the discs so that you can see the gate opening up as you go further down the lock. That's the technique that people use, but again, it's susceptible to error. It's susceptible to things being slightly out of position and getting the wrong codes. Again, by having these 2 new systems, you can scope it, but before you go away and make a key, you can build your key onto this, put it down, and if it doesn't open, you can see immediately where your mistake is. So it can be used as a tool to test errors of other techniques. And that is basically it. That is all the system is. It is a rotary pin and cam system for ABLOY locks. And it's very easy to use and very easy to teach. And that's about it.
John, why is there a difference in the feeling between false gates and true gates?
There's no difference in the feelings initially. What happens is that as you apply tension, the sidebar is forced in against the sides of all the discs. Now, when the sidebar is forced in, it will be against one of 3 different possible surfaces. It will either be pressing on the surface of the disc, which has got the largest radius from the center of the disc. It'll be directly above a false gate, which has got a slightly shorter radius from the center of the disc, or it will be directly opposite the true gate. Now, when the sidebar is pushing against the surface of the disc will go rigid. When it is directly opposite a false gate, the disc will be loose, because obviously it's not binding, there's a gap. But when all the other discs have got opposite the false gate, the sidebar will drop in a little bit further, and it will bind on the base of 1 or 2 of those false gates. So initially a disc will be rigid and then go loose, and you will lose control of it. But later on, you will go back to that disc and it will go rigid because the sidebar is pushing on the base of the false gate. Of course, when it gets to the true gate, it will not bind ever until everything's opposite the true gate, and then, of course, the lock will open. So you won't have any worry about it. The best way to demonstrate this really is when we... well, I'll actually grab one just quickly. I'll get a disc, and you'll be able to see that. Okay. Right. Now, you can see here that this is the largest diameter disc they've ever made. This is the disc. Now you can see what they've done, and that this is the surface of the disc, and this is a false notch. And then there's a surface again, and then there's the true gate, and then there's the surface, and then there's a false. And this is consistent with the locks. The path of the surface of the disc is always into a false, onto a surface, into a false, onto a surface, into a false. It's just that one of those falses will be true. Now, obviously, when you apply tension and the sidebar is pushing against the surface of the disc, it's going to go rigid. When you move it, it's then going to go opposite either the true gate or it's going to be a false gate. So you're going to lose it. But later on, when all of them are in false gates, it will then begin to bind on the base of that false gate. So once again, you will change it, and from there it'll go back onto the surface, and then from there it'll go into the true gate. Or into another false, and then onto a surface, and then into the true gate. It's very similar to any pin and cam system that I make, and I make a lot of pin and cam systems for locks that have false notches, such as the Chubb 110, which was the original lock that I designed the pin and cam system for. On a 110, it's very similar. On the surface of the levers of a 110, there is a surface, false, surface, false, surface, and then it goes into the true gate. Or it could be surface, false, surface, gate, and then surface, and into another false notch. There's false notches on either side of the gate. But on a 110, I think I'm true in saying there's always 3 false gates and 1 true gate, and a load of surfaces in between. It's the same with an ABLOY. If you look at any ABLOY disc, there's 2 falls. In this particular case, I think you'll find that this is probably a 1. So the first gate that this gets to will be the true gate. Then there's a surface, then there's a false gate, then there's a surface, then there's a false gate. So it would never reach the false gates on this particular lock, because the first gate it would go into would be the true one. But all of them are the same. If you look at them against each other, they've all got 2 false gates, 1 true gate, and in between are the surfaces, which are the other codes. So that might be a 1, 2, 3, 4, 5, and then that surface would be the 6 afterwards. You simply have to put it into a lock and play with it to see the differences that you get. Sometimes when you're on a surface, what happens is that as you turn the pick, the disc moves, and you actually feel the sidebar clicking into the false gate. As you progressively turn it round, it's basically on the surface. The surface is only a very thin area that the sidebar can bind onto, and then as you move it, you feel it going click as it drops into the false gate. Now that only happens when it's clicking into a gate. It won't happen when you're in a gate and you're trying to click out of it. So in other words, if you're in a false gate and you move it, it won't go click, because it actually has to come away to go onto the surface. But if you're clicking into a true gate or a false gate, you'll feel that, and as you turn the pick, you'll feel it go click, and then you go, great, I now know that that disc is in a gate. So you don't expect anything else to happen to that gate until all the others are in a gate, and then of course it'll come out and progress around to the next one. And that's basically it.
John, is there any way to measure the distance of travel between when you rotate and put torque? Can you measure the distance of travel into a false gate versus a true gate?
No, because the width of the false gate is the same as the width of the true gate. The only difference is that it'll be binding on it. So, in other words, when you're hovering above a false gate, it feels exactly like a true gate, until it binds on the base of that false gate, and then there's no movement, so that indicates that it's obviously false and you need to change it.
So you're really measuring the width of that gate, or...
Well, you can't measure... Well, the actual angle between the gates is 18 degrees. The angle... the shape of the key cut that operates a 0 is 180 degrees of a semicircle. So the tip of the tool is a semicircle. The shape of a number 1 cut is 100 and what would it be? 62 degrees. That's the 162 degrees of a circle comprises a number 1 cut, which is 18 degrees short of 180 degrees. And the next cut down from that is 18 degrees less again, 18 degrees less and 18 degrees less. And a number 5 cut is just a 90 degree semicircle. With half cuts, which is what I'm using, I've played for midway. So in other words, it's only 90 degrees short of a semicircle for my 0 cut, and then it's 18 degrees short of that for a 1, which is, of course, 9 degrees short of a proper 1. Now, when you actually have a 0 in there, and you're using a half 0, you don't get as much movement. And the reason for that is that the pick is capable of moving the piece 18 degrees, but there's only 9 degrees of movement left. So that is the only exception to the rule. When you've got a half 0 in and you're operating on a 0, you don't get as much movement as you do when you've got a half 1 in and you're operating against a 1.
But the 4 out of 5 cuts, you're actually measuring the when torque is applied, the measurement, so to speak, is against the edge of the gate rather than the center of the gate?
You're not measuring anything. All you're doing is you will find that when the disc is wrong, there is no movement. When the disc is right, there is movement. And there is full movement. There is this amount of movement. There is a screw here which goes into this slot, and that limits how far the pick can move forwards and backwards. Now, when the code is right, it will give you that amount of movement. When the code is wrong, it will not move at all. I mean, there is a certain amount of movement because there's flex. I mean, obviously this pick is long and thin and it bends a little bit, so there will be movement. Now, when you get opposite a false gate, you will get the same amount of movement as when you're opposite a true gate. But later on, you will get no movement. Later on, it will return to that disc, and when you try to move the pick, there will be no movement because the sidebar is binding on the base of that false gate, and it simply won't allow it to move. I mean, it's best to learn this system with the cheap copies, because the cheap copies from Taiwan, such as Baton and Elka, don't have false gates. So what happens is that you start with a disc that's binding, you change it, it binds, you change it, it binds, you change it until it gets to its correct gate, and when it gets to its correct gate, it goes loose. So if you start by using the copies, which are obviously very, very easy to open, and then you introduce discs which have false gates, you begin to pick up what's happening, because what happens is that the ones that haven't got false gates go in, and then you get a little bit of a movement within the lock, which means that the sidebar has actually dropped in a little bit, and then the ones which you've got the false gates on begin to react. And what happens is that they come out of their false gates and then into the next false gate until eventually they get into the correct gate, and then they go loose and they remain loose for the entire period. The only way to really use it is to sit down and see what happens, but the best way to demonstrate it would really be on a model, and it's difficult to get in fact, I do have one cutaway which you can put the tool into and you can see exactly what's happening on the cutaway, but unfortunately it's only a 9-disc cutaway and it's very, very old. But if we had a lock which was cut away so that you could see the discs in there, then you would actually see the discs moving when they're in their false disc position.
So if you made a mistake and actually measured all the false gates, ultimately you'd figure out they're all false gates. If you thought the false gates were true gates.
Well, if you made a mistake, I did make a mistake. On the 4th disc, at some stage, I went past what the actual 4th disc was. And the 4th disc is in fact that's 1, 2, or the 4th disc on here is in fact a 2. Now, when I was decoding the lock, I went past 2. Now, I went past 2 because, well, I don't exactly know why I went past, but what probably happened was that the number 4 disc was slightly out of alignment and was pushing on the next disc past it. And that was rigid, and that made me think that the number 4 was rigid, and I changed it. Now, what happens, I changed it from a 2 to a 3, and then it was rigid. I changed it from a 3 to a 4, and then it was rigid. And then I took the piece out, And when I went in with just the pick, it was still rigid. Now, it's got to be something. So then I took the 4, I put the number 4 back in as a 0 and went down again. And this time when I got to the number 2 position, that was the only thing that was wrong. And then, of course, it opened. You cannot really make a mistake. You can make a mistake, but you will be forgiven for your mistakes because you can put the piece back in. You can simply build the key back up. Unlike impressioning, where once you've filed the metal off, you can't. With this, you can go round and round in circles. It's not uncommon to make mistakes. Mistakes are caused probably more by wear than anything else, and that is that the disc itself has simply worn down a little bit and it's being pushed out of alignment.
So especially though a beginner, if you thought that all the false gates were actually true gates, you'd actually figure it out.
Well, at no stage while I'm decoding the lock do I ever say to myself, that's a false gate. I simply never know. When a disc goes loose, I assume that it could be a false gate or it could be a true gate. But it doesn't matter because the pick is loose and that's telling me to leave it. So I go elsewhere and I find other things that are rigid. Later on, I return to those discs that were previously loose to find that they're rigid. That simply means that the first time when it went into that gate, it wasn't in fact a true gate, it was the false gate. But I didn't know that until the other gates became correct. And now I've gone back to it, it's gone rigid, so I change it until it goes into another gate. And the next gate that it goes into will either be another false gate or it will be the true gate.
So actually, in some respects, there's some real parallels between the technique that you utilize to open this lock and manipulation of a combination lock. You're, in many respects, doing the same thing, except more precisely with this lock.
I suppose, yes, you are. I mean, I'm not that up to date with manipulation to know, but I am sure that when you're manipulating a lock, besides the gate position, there are other low spots within the surface of the disc.
Shadowing.
Yes.
Where you have irregularities in the circumference of a wheel next to the wheel you're testing.
Yes.
And so you're really, in many respects, looking at the same problem. What you're really doing is taking contact readings of that lock.
Yes, but I'm not, unlike a pick. Now, when you've got a 2-in-1 wheel pick, which I would use against an Abbas granite, for example, what you were saying about measuring the gate is exactly what you do. There are false gates, but when you're in a false gate, you get less movement. And subsequently, you can detect that, and you can say, that's false, release tension, and progress it round to the next position, reapply tension. And when you get the correct position, you get this substantially larger movement. And this is because the sidebar is gone into the true gate, and when it's in the true gate, you always get this maximum movement. But when it's in a false gate, it's rubbing on the false gate and you get a little bit less movement. But we can't do that with this system because each of these pieces is only capable of moving one increment, whereas on a wheel pick it's capable of moving the disc from the 0 to the 5 position. With this I can't. So what I'm relying on is the fact that the guillotine or the sidebar is always going to drop straight down, and the only place it's going to always be loose is when it drops down into a true gate. But when it drops into the false gate, it's still going to give me that rigidity, provided I apply enough tension.
Well, but it's really not always dropping straight down, is it? If your first, let's say your second, you've decoded properly your first and second disc, then is not your sidebar going to drop at a slight angle?
Not really. I mean, yes, in principle what's happening is the lock is turning a little bit more, but the sidebar sits, if I've got a sidebar, no I haven't, the sidebar sits in a slot on the core.
Right.
The discs sit within that core, and the sidebar is prevented from dropping fully in by the surfaces of the discs. Now, if I use this disc as an example here at the face, and I put it in its start position, you can see that that sidebar is pushing on the surface of that disc, like so. As I turn that disc, it goes into the false gate, but it's still coming straight down relative to the core. It then goes onto the surface, and then it goes into the true gate, and then it goes onto the surface, and then it goes into the false gate. And the 6 cuts are exactly that. That's 1, that's 2, that's 3, that's 4, that's 5, and that's 6. So the cuts on the key will always put the sidebar opposite the centre of a gate, be it false or be it true. Or it will place it on the centre of a surface. And then when it's pushing on that surface and my tool is trying to move the disc, if it's pushing on anything, it will prevent that disc from moving. And I will feel that on my pick. And that's basically all you're trying to do.